So in the last video, you converted hexadecimal numbers to and from the decimal number system. And I had said that hexadecimal is valuable because it's a compact way of representing binary, which is really cumbersome to use. So how does that work? Well, let's look at it by example. So what I want us to start with is to convert the number 17, which is a decimal number, this is actually 17, to binary and to hexadecimal, and we're going to compare those two representations. So let's start with binary. Okay, so we look at 17. And, I think about 17 and I realize, okay, well, 17 is 16 plus 1, right? So that's pretty easy to work out. So 17, if I'm in binary, I'm going to have, a 1 and then no 2s, no 4s, no 8s, and a 16. Okay, so 16 plus 1 is 17, right? Perfect. There's my binary representation of 17. Now, in hexadecimal, right, if I want to take that 17, think about that. Again, it's 16 and 1, right? Well, that's good because 16, is a place value. So I'm going to go the other way. I'm going to do largest to smallest here. So 16, that's going to be a 1 in the 16's place. Well, that leaves 1 left over for the 1's place. Right? So there is my hexadecimal representation. And actually, let's use our notation for those so that it's clear. So in binary and hex, we've got our two representations. Okay. Now, what I want you to realize here is this number 1 in the binary representation is actually a 16, right? So if I look at that, I realize that's actually a 16. And that's actually a 1. As it looks, right? And likewise here, this 1 in this hex representation is a 16, and this is a 1, okay? And so I can sort of see how the hex is kind of containing the binary, and there's some extra left over in the binary that doesn't show up in the hex. Let's explore that a little bit further. Let's do the same thing with the number 26. We're going to convert 26 to binary. Okay, well, 26, put my 0b there. The largest value that goes into 26, that's a power of 2, is 16. So we'll put a 1 for a 16. That leaves 10. And the largest power of 2 that goes into 10 is 8. Okay, well, that's the next place value down. 16 and 8. And then if I take away 8 from 10, I'm left with 2. So that means no 4s, a 2, and no 1s. Okay, and you can kind of verify that that's the correct representation. 16 plus 8 is 24. 24 plus 2 is 26. There we go. In hex, 0x for hex, we've got 116 again, right? And that leaves with 10 left over. But 10 is a digit. 10 is a digit in the 1's place in hex. The digit for 10 is A. And so I've got the hex value 1A. Okay? And I want to compare these two representations. Well, this 1 is a 16. Right? Just like this 1 is a 16. But here where I have A, I've got 4 binary digits that represent that. Well, what are these 4 digits? Well, 0 is 0. This 1 is in the 2's place, 0, 4s, and 8. Well, this is 10, right? This is 10 in decimal. But 10 is A in hexadecimal, right? These two things are equivalent. So the hexadecimal digit is actually containing 4 binary digits. And that's true of every hexadecimal number. Every hex value, every hex digit contains 4 binary digits. And so if you know the binary representation of each hex digit, then you can just write those in a row and you actually get the value that you want. So let me show you what I mean by that. Let's convert the hexadecimal value B4F to binary. Well, the beautiful thing about hexadecimal is, again, each hex digit contains 4 binary digits inside it. And so all you have to do is write down those 4 binary digits in a row and you get the binary value. So for the value f, that's 15. Well, 15 in binary is 1111. It's 1 less than 16, which is the next place value, right? 4 in binary is 100, but we have to be careful because we're in the middle of a hex digit. Every hex value is held by hold 4 binary digits, so you have to include that leading 0. Okay, watch out for that. So every hex digit is 4 binary digits, even if it doesn't need 4 by itself, right? Like 4, you could do 100, but because it's in the middle of a hex number here, it really represents 4 binary digits. So we write that as 0100. The B is 11. 8 plus 2 plus 1 is 11. And so there is B. And if we just smush those 3 values together, we get the binary answer that represents that value. Okay, so it's a nice, easy way to convert between hexadecimal and binary. If you want to go the other way, you just do the same thing. You start at the far right. You take each digit 4 at a time and turn it into a hex digit. Okay. Really simple. If you have any trouble, let me know or talk to a neighbor. Let's look at how we can do that in Python and convert back and forth between values, and you can check yourself. So I'm going to go back to my terminal window here. We've been playing around with some binary numbers before. You can do the same thing with hex values. So let's say I wanted to know what's the hex value of 19,070. And we had done this before. And we got 4A7E. Okay, so there's my hex value. You can check, right? You can also go in the reverse direction. Let's say I want to know what the decimal value of B4F is, right? We just did B4F and we saw what the binary representation was, right? The binary representation is this long 12-digit binary number. The decimal representation is 2,895. Okay. I can check to make sure my binary representation was correct by just doing binary 2895. And I get that 12-digit number, and that number should match the binary value we have here. Okay, so you can kind of go back and forth between these numbers. You know, again, if I type OB101101001111 and hit enter, it will convert that to a decimal number for me. And I can check, yes, it's the same. So all these are the same value, just represented in different number systems. Play around with that. Make sure you're able to convert between binary, decimal, and hexadecimal numbers. And if you're having any trouble, again, talk to a neighbor or ask me questions. Good luck.